Some black holes are barely heavier than a single star. Others are so massive they hold entire galaxies together like cosmic anchors. And then there are the ones that might not exist at all, theoretical monsters that defy every rule we thought we understood about the universe. Today, we'll descend through 5 levels of black holes, from the smallest stellar corpses to the most mind-bending enigmas known to science. But before we dive in, let's answer the question that starts it all. What exactly is a black hole? At its core, a black hole isn't an object in the traditional sense. It's a region of space where gravity has gone completely rogue, so strong that not even light, the fastest thing in the universe, can escape. Imagine compressing the entire mass of our sun into a sphere just a few kilometers wide. The result? A tear in space-time itself, a one-way door known as the event horizon, the ultimate point of no return. Anything that crosses it, from dust and gas to information itself, is gone forever. To the outside world, it simply disappears. And yet, despite their terrifying reputation, black holes aren't cosmic vacuum cleaners roaming the galaxy. They are the natural consequence of physics taken to the extreme, the endgame of gravity, when nothing else can resist it. Our journey begins with stars, the brilliant engines that light up the universe. Like all living things, stars have lifespans, and when the most massive ones die, they go out in spectacular fashion. A star at least 20 times heavier than our sun will collapse in on itself when it runs out of fuel. Its core implodes. Gravity crushes everything to infinite density. What's left behind is a stellar black hole, a city-sized object weighing as much as 100 suns. Pause for a second and imagine that, a few kilometers across but containing the weight of millions of mountains. If Earth somehow swapped its core for one of these things, the planet and everything on it would vanish in an instant. But how do you find something that emits no light at all? We look for the chaos it causes nearby. When a black hole steals gas from a companion star, that gas spirals inward, forming a disk that glows in X-rays hotter than a million suns. That's how we found Cygnus X-1, one of the first confirmed black holes, about 6,000 light-years away. Even Stephen Hawking bet against it being real and lost. Today, astronomers believe there are millions of stellar black holes drifting silently through the Milky Way, invisible, untouchable, waiting. If stellar black holes are the seeds and the giants at galaxy cores are the trees, what lies in between? Logic says there must be middleweights, black holes hundreds or thousands of times the mass of the Sunday. We call them intermediate black holes, but finding them has been one of astronomy's greatest challenges. They're too big to form from a single star and too small to power the bright beacons of galaxies, so they hide in the dark hearts of dense star clusters or tiny dwarf galaxies, leaving only faint fingerprints in the orbits of surrounding stars. One strong candidate, HLX-1, sits 290 million light-years away, likely weighing around 20,000 suns. It's a rare glimpse into a missing chapter of cosmic evolution, perhaps the bridge that explains how small black holes grow into the monsters that rule galaxies. Yet we found only hints, never proof. Are these ghosts simply too quiet to detect? Or is nature skipping this step entirely, leaping from stellar to supermassive in one unimaginable jump? Now we reach the true titans, the supermassive black holes, objects so vast that their mass can reach billions of suns. And they're not hiding in deep space. They sit right at the centers of galaxies, including ours. At the heart of the Milky Way lies Sagittarius A*, about 4 million times the mass of the Sunday. We can't see it directly, but we can watch nearby stars slingshot around it at speeds of thousands of kilometers per second. Only a monster like this could explain their motion. In 2019, the Event Horizon Telescope captured the first ever image of such a beast, the black hole in galaxy M87. That glowing ring of light surrounding a dark void was humanity's first glimpse of the edge of an abyss. But how do these giants form? No single star could ever collapse into something this massive. Some theories suggest they grew over billions of years, devouring stars, gas, and smaller black holes. Others propose that they were born directly from colossal clouds in the early universe, skipping the stellar phase entirely. Whatever their origin, their influence is undeniable. They shape the galaxies they live in, regulating star formation, sculpting galactic structure, and powering quasars bright enough to outshine everything else in the cosmos. They are both creators and destroyers, cosmic architects, controlling the rhythm of galactic life itself. But what if some black holes are older than stars themselves? Imagine the universe less than a second after the Big Bang, hot, dense, and chaotic. In that primal soup, tiny ripples in space-time might have collapsed instantly into miniature black holes. These would be primordial black holes, relics from the universe's birth. Some might weigh no more than a mountain, yet be smaller than an atom. Others could be as massive as thousands of suns. If they exist, they could solve one of the biggest mysteries in modern physics dark matter? What if the invisible mass holding galaxies together isn't made of exotic particles at all, but of countless tiny black holes drifting silently through space, even through us every second? It's an astonishing idea, but so far, purely theoretical. We search for them by watching for gravitational lensing, tiny distortions in starlight, or flashes of radiation from their possible evaporation. If we ever find one, it would rewrite our understanding of both cosmology and quantum physics in a single discovery. Now, let's shrink our perspective to the smallest scales imaginable. What happens when gravity and quantum mechanics collide? This is the domain of quantum black holes, objects smaller than atoms, possibly formed at the Planck scale, the smallest distance that has meaning in physics. These would be black holes no larger than 10 to the power of negative 35 meters, yet infinitely dense. According to Hawking's theory, small black holes radiate energy and eventually evaporate. A Planck-sized black hole might vanish in a fraction of a second, releasing more power than a nuclear explosion. We've never seen one, but some theories suggest they could be created momentarily in high-energy collisions, maybe even inside the Large Hadron Collider. Even if they appear only for a blink of time, there'd be priceless experimental glimpses of where quantum physics meets gravity, the key, perhaps, to a true theory of everything. Beyond these 5 levels lie stranger possibilities. Binary black holes, locked in a death spiral, merging in cataclysmic collisions that shake the universe itself, the source of the first gravitational waves ever detected. And even more exotic concepts, like white holes, theoretical opposites of black holes, objects that can only spit out matter, never take it in. If black holes are nature's ultimate traps, white holes would be nature's ultimate escapes. They may never exist, but they remind us that physics is still unfinished, a story still being written. From the collapse of dying stars to the birth of galaxies, from quantum whispers to cosmic giants, black holes are the universe's most extreme experiment. They're not just symbols of destruction, they're windows into creation, into the very structure of reality itself. So now, I'll leave you with a question. Which level of black hole fascinates you the most? The giants that shape galaxies, or the quantum ghosts that might vanish before they're born? Let me know in the comments, and if you want to keep exploring the strangest corners of our universe, subscribe, because this is only the beginning.